So today we are talking on natural language processing. So with this, I welcome you to the second episode of natural language processing. This is Dr. Rama Satish. I hold MCA, M.tech, PhD degree. Basically, I am a professor at RNS Engineering College, Bangalore. Last episode, we had discussed about NLP workflow. The process begins with text processing, which involves cleaning of the text. Later, in the next stage, exploratory data analysis, where we use a technique called word to vector. So that means the words that are there, that are in English words, we are converting into numerical values, that is, and storing into vectors. In this case, there are some chances of misspellings, spelling mistakes. So correction of that spelling mistake is the challenge that NLP is facing. And we are going to do that. I'll show you in our implementation. We will take you some text, misspelled text, how NLP corrects those text. We will demonstrate that also. Further, it has to be the vector, whatever we have explored, it has to be represented that focuses on tokenization, converting the text to sequence and padding the sequence to ensure consistent input formats for modeling. So once the model is created, so during model, what happens? You apply advanced algorithms such as by LSTM, GRU. So these algorithms will finally create a capsule network to learn from the processed data. Finally, deployment involves using the trained model for predictions and evaluating this performance of the NLP system in the real world, whether it is really working fine or not. Is there any corrections that are required? So that has to be done in evaluation of NLP model. So that's about the thing. So in order to understand all these things, and if you have not seen the previous episode, there is an I button coming up. You can see the previous episode, and of course you can come back and proceed with this episode. We move on to the first stage, that is pre-processing in NLP. So pre-processing as the meaning says, before actual process starts, you need to clean the data. Incoming data is raw data. There are some mistakes, there are some errors, all those things, it has to be cleaned. So that cleaned text input, if you give it to the system, so you get the clean output, perfect output or accurate output. So that is the thing. So here in data pre-processing, actually is the process of converting the raw data or unstructured data, which are potentially noisy data. Noisy data in the sense you have lot of errors in it, and they are fed into the pre-processing system in order to clean and well organized data set, in order to make it as well organized data set suitable for analysis, suitable for modeling. It ensures that data is of high quality, consistent across all the records, and relevant to the problem being addressed by performing processing, such as handling missing values, correcting errors, and understanding the formats. The data set becomes more reliable. As it becomes more reliable, what happens? You get clear output. So this pre-processing step is crucial because well pre-processed data enables the machine learning models or NLP models to train more accurately, more efficiently, ultimately improving the performance of the trustworthiness of the results. Data transformation is a technique that involves normalization or standardization of the data and encoding to convert data into a suitable format for machine learning algorithms. Of course, machine learning algorithms are nothing but the NLP algorithms also. Data reduction. You have to reduce the data. Sometimes data is simply repeated multiple times. You have to reduce to a small, precise format. So data reduction follows aiming to simplify most relevant features while preserving the important information. Last step in data pre-processing is data integration. Data integration is nothing but data is coming from various sources and you have to bring them to a common format by merging the data that are coming from different sources into a unified data set. This will ensure the consistency, this will ensure the completeness for data analysis. Altogether, these steps ensures the data is accurate, well structured and optimized for modeling. That is what the data pre-processing is all about.
Data cleaning, that is text pre-processing. First, see, I have a data set called a Twitter sentiment data set, which is a small file which is available. I have loaded to my drive. You can just see this. Just open it. So it is containing all the tweets that are captured. You can see there are so much of data captured. It is around 3,197 records are there. So total. So you have so many data is available. So now what we do, we import this data. You can see here we are importing the data, and of course once we import this data, you can see we are displaying first 10 lines. So DF, data frame, we are displaying. As I run this, so it will display, yes, first 10 lines it is displaying. And further, next, as a part of our discussion, so we have to convert all the text to lowercase. So it is in processing, pre-processing. So we are converting whatever the data that we have read, that we are all converting into lower. Yes, we are converting. Look at here, as I run, it will give me the result. This is my data. All data, irrespective of letters, they are all converted to lowercase. So that is the thing. Next, removal of punctuations. This is again another pre-processing technique. So here, these are all the punctuations that we are removing. So it is removing all the punctuations as I run this code. So it is removing all the punctuations. Yes, you can see all the punctuations are removed. All the punctuations are removed. Yes, you can see it is. So you can remove all the punctuations. Yes, it is removed. So earlier text, you can see that text is having @ symbol and all those extra hash symbol and all those things. So this is the original. This left side is the original and this is pre-processed, cleaned text. This is the data and this is pre-processed data. Now, a removal of stop words. What are the stop words? First, in order to do so, stop word removal, you have to import NLTK. This is the library that is used. NL, Natural Language Toolkit, NLTK. This library has stop word. All the stop words you can download, and you can certainly process it, and you can remove it. You can see as you run, it is displaying. This is a simple sentence stop removal. So what it is doing, first it is downloading everything and it is keeping ready. Then it is removing. You can see some, been. So you can see so many. One. So many stop words are there. All the stop words are removed. And it is done. Same thing we apply to our data set, pre-processing data set. Here also, you can see as I run this. So it is taking all the tweets data, and from the tweets data, it is removing all the stop words. So clean text is removed. So that is, and I told earlier, we have to even tackle the spelling corrections also. So you can see there is a spell checker, spell checker, which is needs to be used here. So I'm using. So before that, I'm just getting it ready, downloading it, installing it. Yes, it is installed. Its requirement is already satisfied. Later, so I have a word, C for computer. You can see here COPUCMPUTR, and you can certainly water for spelling of water, WATR I have written. Study is proper, and write, WRTE I have written. These are all the spelling mistakes purposefully I have written, and I am feeding to the system, NLP system. When I am feeding this, you can see that it is corrected. You can see CMPUTR is corrected as computer. WATR is corrected as water properly. WRTE is corrected as right. See, this is what you call it as pre-processing.
Further, the benefits of data pre-processing. As I have already said, the benefits of data pre-processing is you can get very accurate results, the first thing. And the training of the machine training time becomes short. Very quickly the machine can understand. Very easily machine can understand. Further, it prevents the biases and noise from distorting results. Further, pre-processing makes data understandable and usable very, very efficiently. So this will create a well-structured data set that supports better decision making, better interpretation. So quickly they can process, easily they can process, and not only that, you get accurate results. You can achieve 90% accuracy, 99% accuracy. And NLP pre-processing, you can see on the slide, you have the workflow, it is given, and pre-processing is essentially the first step in pre-processing the raw text, and this can be effectively analyzed and modeled by natural language processing. The raw text is often contains noisy. What are noisy? Punctuations, some special characters, inconsistent capitalization. That means somewhere in between you have capital letters. So that is inconsistent. So all these things, it has to be normalized. Irrelevant words are added. So which can hinder the model to understand, and it can affect the performance of the model. Of course, pre-processing techniques like tokenization, stemming, lemmatization, all these things will bring the text to a very standard form, and Once you get the data or the text to a standard form, the process, further process becomes very easy. So you get improved consistency, and ensures that data is fed into the algorithm very clearly. Algorithm easily understands it, directly impact the accuracy and efficiency of downstream NLP tasks like sentiment analysis or machine translation or information retrieval or anything like that. It becomes very, very, very easy. So first thing is NLP pre-processing is very essential. Further, the key pre-processing steps, as I said earlier, first one is tokenization. Second is stop word removal. Third one is stemming. Fourth one is lemmatization. Tokenization, stop word removal, stemming, lemmatization. If you do all these things, your data is cleaned. So now we will understand what is the meaning of each of these. And at the end of this episode, we'll also see how tokenization is really working. We'll feed some data and how tokenization happens. We'll feed some data how stop word removal happens. We'll feed some data how stemming happens. We'll feed some data how lemmatization happens. Now let us understand the meaning of tokenization. Tokenization involves splitting the text into smaller units like words, sentences, sub-sentences or sub-words, enabling common structure analysis, easy structure analysis. First thing is the lengthy sentence, it has to be divided or tokenized into words, small words, so that each word can be understood by the NLP system clearly. So that is the first stage. Second, stop words. What are stop words? Stop words are common words that are having very low information words. For example, is, is, or the. These are all, of course, they are used, but without that also you can understand. Stop words, and these stop words, it has to be removed. Why? Stop words are many times repeating and unnecessarily it becomes a lengthy input. So if you remove it, of course they don't have much value to the processing, so they will be removed. Stop word removal, that is the thing. And sir, what are the stop words available in English? Definitely for that we have in code implementation. I'll show you first what is stop word removal and how many stop words we can list and how many stop words are there in English that are not essential for processing, NLP processing, and later I'll show you how these are removed. Stemming. Stemming is nothing but trimming the words to their root form by removing the suffixes, often without considering the grammar. For example, running can be stemmed to run. The actual meaning is run. Next, we have lemmatization. Lemmatization is also reducing the word to their base form. Of course, there is a difference between lemmatization and stemming. In stemming, you are just removing the excess words, ing or some suffix words that are there, you just remove. But in lemmatization, you also check whether it is having the right meaning, dictionary meaning, whether it is having dictionary meaning. For example, best, better, they are all lemmatized to good. That means they are reduced. Better is also reduced to good, best is also reduced to good, good is also reduced to good. So that means they ensure that grammar accuracy is maintained. That is what lemmatized. And together, all these steps makes text more uniform and reduce the dimensionality and improves the model performance. Let us move on to the code implementation. Here comes your code implementation.
We are going to show implementation of tokenization. Stop word removal I have already covered in the previous episode. We'll be talking on stemming and lemmatization. So quickly, as soon as I click on this, it will take me to collab page. Yes, my collab page is already ready. It is running. I just have to skip. So tokenization, for your information, it is the process of breaking down your text in natural language processing into smaller units of sentences or words. We call it as tokenization. So for this, we are making use of NLTK library. So you can see NLTK library. It will give a few information about NLTK library. The same link will be shared in the comment section. You can certainly use. We downloaded the 3 dependencies, punct, wordnet and puncttab. So all downloaded and ready. It is ready. Now I have a sentence now. So I am almost dead this time. This sentence I am just running it by clicking. So I'm just running this click. So when I run, so I get the output. I am almost dead this time. So this is word tokenization. Now I have another example here from NLTK tokenize import sentence tokenization. I have 2 sentences. Welcome, hello everyone, welcome. You are studying NLP article. 3 sentences are there. So when I run text tokenization here, my tokens are created. 3 sentences are tokenized. You can see tokenized. It is done. Next, character tokenization. For character tokenization, I am giving the same sentence and I am running character tokenize. As soon as I run this, click, it tokenizes and it gives every character as a token. It runs like this. Similarly, I can tokenize the subwords also. I can get into subwords also. I can get the subwords. Yes, tokenized. Subwords also are tokenized. So it is. So further, stemming. For stemming, we first understand what is stemming. Stemming is nothing but it's a NLP process that involves reducing the words to their root form or base form of by removing the suffixes. So here you can see we are making use of snowball stemmer for doing so. So I'm just running this code. As soon as I run this code, what happens? My words are running, runner, runs, easily, graciously, universal. So all are stemmed. You can see output I am getting. From the porter stemmer I am getting the output, as well as snowball stemmer I am getting the output. You can see running is turned into run, runner into runner, runs into run, easily into EASILI it is showing easily, because it is stemming does not follow grammar rules. So that's the problem. Graciously is gracious, generously is nothing but gener, universal is nothing but universe. That's all. So both are doing the same way. Whereas lemmatization is a natural language processing where the process reduces the word based on its dictionary form. Dictionary to the dictionary form. That means a proper meaningful way. So here I download the required components. Once done, I just run. I give the cats were running faster than dogs. So when I lemmatize these words, you can see lemmatize the words. So when I run this, the original text is this. The lemmatized words are the cat, S is removed, were is remaining as it is, running is taken as it is, faster than the dog, S are removed. This I am using word tokenization, word tokenization and lemmatization. I am doing it. So I am doing it with WordNet Lemmatizer. Now, the same I am using much more. I am using POS tags and I am doing lemmatization. So the words are, you can see the sentences, the stripped bats are hanging on their feet for best. So here you can see the is a tokenized and stripped bats. They are all tokenized as a bag of words, small words. You can see BOS, small words, they are tokenized. Same way, so I can certainly tokenize, I can certainly lemmatize the words. The stripped bats, you can see stripped bats were be hung on their feet as tokenized to foot for best. You can see this. So that means there is a lemmatization happening based on NLTK POS tags, based on NLTK word tokenize with the tokenizer. So lematizer is another tool.
Hope you have seen the implementation part. But before we end this episode, let us look into the brief. What is tokenization? Tokenization is splitting the words into smaller units like tokens. And tokens can be words, sentences, or subwords. Why tokenization matters? Because it impacts the feature extraction. And it affects the downstream tasks like parsing and classification in NLP. Further, the types of tokenization: word tokenization, sentence tokenization, and subword tokenization. Look at the example. I think you have to correlate with the demo that you have seen. I love NLP. It is tokenized as I separate, love separate, NLP separate. Sentence tokenization. I have two sentences. Hello world, I love NLP. So both are separated as two sentences. Look at there. Hello world as one sentence. I love NLP as a second sentence. Tokenization. Subword, splitting the rare words into smaller pieces. That is bringing into subword. It uses BERT model as well as GPT model. The same GPT you are using in Chat GPT. I think probably you will see this as an application you have already used. And last component is character tokenization, where each letter is tokenized. N space L space P, and you also have I space, S space, F space, U space, N space, and even exclamatory is also taken. So that is, of course, the same thing you have implemented using NLTK library. You have seen that. Challenges in tokenization: handling punctuations, contractions, as well as special character handling. That is the thing. Of course, we use NLP word tokenize. I think you have seen in the implementation. So we have used NLP tokenize, the tool that is going to help in tokenization. Now, coming on to stemming, I told, stemming is nothing but bringing those words into its root form. Here comes a very good example you can see there. Stemming reduces the word to their root form, and here I gave one example earlier, that is running as run. Suppose I take some 4 words: dancing, danced, dancer, dances. All these are stemmed to one particular word, that is dance. So that is the thing. There is an algorithm. There are some algorithm that apply the rules to remove affixes and suffixes from the word, aiming to obtain the core or root form. These rules are often based on linguistic patterns, and they are heuristic. So heuristic is nothing but based on the proper meaning. For instance, Porter Smart Stemmer, there is a algorithm. This particular algorithm is a very popular algorithm that we use in our implementation. This algorithm uses a series of language rules to remove the suffixes, to stem the things. So removal of suffixes, I call it as technically stemming. So this Porter stemmer uses language rules to stem. So you will understand in detail in the upcoming slides. So why to use stemming? Stemming is actually a natural language process technique that reduces inflected or deviated words to their base meaning or root form, known as stem. This process has several advantages. One is normalization and reduces the vocabulary, and the second thing is it improves the information retrieval and searching capability, especially for search engines, and next enhances the text analysis and classification. Finally, the computational efficiency and also addressing out of vocabulary issues. I was telling in the earlier episode the challenges. So NLP can handle different accent, different vocabulary also efficiently. How this is done? This is done because of stemming. Stemming can help mitigate the out of vocabulary problem where a model encounters words not present in its training vocabulary, but also it can handle. How this is handled? By stemming unknown words to the known stem, and the model can still process them efficiently. So very clearly you can work it out. And there are very good algorithms. I told already, Porter stemmer is one algorithm. This is the oldest algorithm and most commonly used algorithm. The next one is snowball stemmer algorithm. This is the latest algorithm that we are using in our NLP. So the method is rule based. Here it is dictionary based morphological analysis method it is used. The output may not be valid in terms of stemming. In lemmatization, a valid dictionary word kind of stemming happens. Stemming is faster, lemmatization is comparatively slower. Accuracy, very low accuracy in terms of stemming, and highly accurate in terms of lemmatization. And of course, the context is not checked in lemmatization. In stemming, it is checked. So even stemming is also required, lemmatization is also required for pre-processing. So with all these, I think you have to understand the lemmatization, stemming, tokenization, stop word removal, all are very important phases of NLP text pre-processing. Unless you pre-process, you won't get the proper output. So with this knowledge, the textual knowledge or the theoretical knowledge plus the hands-on or the demonstrations that I have shown, I think you might have understood what is the importance of NLP pre-processing and how exactly NLP is going to work. Yes. Thank you for your attention. In the next episode, we'll meet with some other interesting topics. Thank you.
GTTC, ಭವಿಷ್ಯದ ತಂತ್ರಜ್ಞಾನ